Patrick will be back to pick up with you.
Okay. All right. So we're going to start with chapter 2 today on the C++. Before we start, I just want to mention a couple of things. You might have received some notes from me about your program being copied from somebody else. I was a little disappointed to see some of those things. We can talk individually if you want to talk about it. In this class, I am very particular about you doing your own work. I'm not saying to not help each other. I'm not saying not to work with each other, but there is a difference between making your own program and getting help and copy and pasting somebody else's program. So I have been around and I can see your program and I kind of say, I mean, I can be wrong once in a while, that the program is not yours. So if that is your plan, be sure it's not going to happen here. So if it was a mistake last week, we can fix it up. That's not a problem. But if I catch you guys later on doing the same thing, not only are you going to get F in the class, you will get reported to the school, and that's going to look very, very bad in your records. You don't want to have that. So if that's the case, then you're better off to drop before the drop date. Let some people who are waiting to get into the class. Other than that, we can work it out to see what has happened, and we can look at those. That's one thing. Second, and before I forget, that means that if you're sharing your program with somebody else, you are as guilty as the other person. So if you're giving somebody else's your program, you're both going to get 0. So don't think that I didn't do anything, this person copied from me. You will both get the 0. So be sure that's not going to happen. Yes, sir.
Let's say someone is looking at your program and you tell the person to stop looking at the program. That, let's say I'm the person typing and then another person looks at my program and I'm not fine with it. What should I do?
You tell me and I take care of it. We beat up the person. Okay, another thing I want to bring to your attention, if you are available tomorrow around lunchtime, the Computer Science Club is having their first meeting at 12 to 1. They usually have it on Thursday in lunchtime because that is open hour for everybody in the campus. It's going to be right here in this room. I think it's going to be a very good thing. I think it looks very good in your resume and even in your transfer. More and more companies are looking for computer programmers or computer scientists or anybody who's doing computer or engineering to work as a team. The time that I want to be alone by myself and write my own program has passed. I mean, you ask me, I'd rather to do work by myself. But that's not the way the industry wants it. So seeing that you are part of a club or even doing some kind of a responsibility in there or working in a team, that's going to look very good in for your resume, and I'm pretty sure some of the schools are looking into that and considering to take you into the school or not. Because if you can work with other people, most likely you're going to be a good candidate. If not, then we might have some problem even finding you a job. So that's for the computer club tomorrow, Thursday. Any general questions? I'm going to try to do this a little fast so we can have a little time at the end so we can go over some of the stuff. I did finish up all the assignments. Take a look at the grading. If there is any issue, we can look at it together. If there is a problem, the first week or second week, I give you a little leeway. The biggest problem we have in the industry is programmers are not writing the program that they are asked to do. So we have to pay attention to the requirement. If requirement is asking for something, we have to do that. If you want to be creative, I encourage that. You can go beyond that. But we have to cover the assignment. We have to cover the basics of the requirement. So if you want to be creative, let me know. I don't have no problem with it. But still, that doesn't mean you're not going to do the basic. That, once again, means that if you have a different book, it's your responsibility to find the assignment. I'm not going to be emailing it to you. I'm not going to tell you what the assignment is. You have to figure out how you're going to get it. So when I ask for assignment 1, 2, and 5, for example, those are the assignment I'm looking for. For any reason that's been changed, that's going to be a flag for me that something is wrong. So if I ask in the assignment, enter 2 numbers and add them together and multiply them together, and you are talking about some rectangular area and perimeter, I don't know. That is not what I asked for, so most likely we're going to have a problem. Okay, so the basic assignment has to be covered. Then you want to take it out and expand it to area, perimeter, and you want to do some more stuff. I'm with you, and I like you do that, and I would be happy to look at those things. But the minimum requirement has to be met. Any questions? Any concern? Anybody want to leave right now so we can give you a seat to somebody else? I haven't scared you enough yet? No, it's not working. No questions? Everything's good? Okay, we are starting chapter 2. Okay, so the question was, what's the difference between the compilers? As we go along, remember, the file that you are typing for C++ is just a text editor. So it's just a text file. And you can type that in anything you want. And then you're going to use the compiler that's going to go through this to figure out the syntax and figure out the library and all those things. So what we have, different types that you are doing, is not actually the compiler itself, it is the editor that's going to make it a little nicer and easier for you to use. So some compiler, editor, or whatever you want to call it, or for example have the keywords different color, or if you're typing something wrong, it's going to highlight it for you. So it's going to be a little more user friendly than the other one. So if you're using the code block, you have to have a compiler of, what is it using? GWCC, something like that. And then it's got the editor, so it has to connect them. That's the tool chain is about. So did I answer your question?
Syntax is the same, right?
Yeah, the C++ is C++, no matter what you use. Yes. Yes, that is correct. You can actually use it in the command line. You don't even have to have any kind of editor like that. You can write it in a notepad, save it, and use the command line to compile it. So you don't even have to have the editor. Any other questions? Okay, so we're going to be talking about the variables and assignment. We're going to talk about the input, output, data type, simple flow of control, and program style. So we're talking about the variables. On the computer science book, you are looking at memory locations and all those kind of things. So when we are writing program, the first thing it does when it wants to run is going to go and save some spaces for the variables. So when I create a variable, that's going to be assigned to an address, a location in the memory that I can save something in there. So that's going to be a number, or it's going to be a character, or it's going to be a name, or a string, or something that we can save in there. So in this case, I have double an int. We're going to talk about the difference between those things, and you can see the way that we are defining names, the variables that has to be defined in a user-friendly way, and we talk more about those. So what we want to do is we want to have a user-friendly names that represent data to be stored. So A, B, C, D, those are not a good names for the variables. We can start with the character or an underscore. It has to be character or underscore. In real life, we're using the underscore for some other stuff as a convention. Nothing that it says you cannot do it, but that's only you can do. The rest of it can be letter, number, or underscore. You cannot put a star or parentheses or things like that in your variable name. It has to start with the letter or underscore. Keywords are some words that C++ it has a special meaning in C++. So it's looking for those keywords to do something. So if it is already reserved for it or it has a special meaning for C++, I cannot use it for the variable or identifier. So those are special key. If you have a good editor, it's going to usually change the color on those things so you know what it is. Before use variables must be declared. That means we have to say how much of a space do we need, what type of things is it. Basically is how much of a space do we need in the memory so we can allocate, or the computer can allocate the memory space for it. So the way we're going to do it, we're going to put the word int, double, and we have some other things that's coming in, and then we're going to define a very good name for it. So the convention is either you're going to put underscore between them, or you can start with the lowercase and make every other word uppercase. I mean, the O over here is going to be uppercase, the B is going to be uppercase. So you can do it that way or this way, however you're going to be comfortable with. So if it's an integer, int is integer, that is for numbers without decimal point. So integer is numbers without the decimal point, and double is for numbers with decimal points. So we can have our variables declared on the top of the program. That is my preferred way because I can see everything, and I'm coming from the C programming, so that's the way we were forced to do it. But in C++, you can declare your variable in the middle of your code. It's nothing wrong with it, but the problem with that is if you declare it in the middle of the code and you have some braces, outside the braces, this is not going to be visible. So we're going to have the type name and the variable. So we can do it two ways. Either we can separate them by comma, or we can put a semicolon and start with the name again. So I could potentially put this moon distance right here with a comma right after that. So the semicolon is going to end this variable type. So here I have int, I separate them by comma, I put a semicolon, I go start another int over here. You want to do all of them in one line, or you want to do it in multiple lines. That's up to you how you want to do it. Any questions so far? Yes, sir. Say what again? Okay, we're gonna look at those things. What will happen? The question is, what's going to happen if you change integer to double or double to integer? First of all, if you don't have anything in there, of course you're going to get a compiler error. But if you have one of them and you want to put it in the other one, then we're going to have a problem. If we have, these are all about the sizes. We're going to look at it later on. So double is much bigger than the int. So if I put the bigger things in a smaller thing, something's going to fall off. If I put the smaller thing in the bigger one, that's not a problem. So if I have an integer, I want to put it in double, a smaller to bigger one, no problem. But if I put a double inside the integer, what's going to happen is going to lose its decimal points. And we're going to look at those things. Okay, equal is for the assignment. We want to mention it as assignment. It is not an equal sign. It's not an equality in C++. It's assigned. That means it's going to go take care of the right side, and it's going to assign the result to the left side. That's for the assignment. So they call it assignment operator. It's not an equal sign. So if I say age equal 21, it's going to take the value of 21 and it's going to assign it to age. Or I can say my cost equal your cost. It's going to go get the cost, your cost, and then put it in there. Or of course we can do some kind of a mathematical formulas that we're going to get into those. So the sign that we're looking at, it is not the equal sign. It's called assignment sign, and we talk about it, that why they are forcing to think about it as assignment, not the equal sign. Questions? Go back. Yes, sir. Okay, so now we can declare the variable and we can initialize it at the same time. The reason we want to do that is, first of all, there's two reasons with that. First, if I have an initial value, I want to put it in there. So mile per gallon, I'm going to initialize it to 26.3, and later on I can change it. That's not a problem. Second is, if I have some variable that is going to be in the right side of the equation, that means it's going to be used in some kind of a calculation. If I don't have any value on it, the computer is going to go pick up whatever is on the memory for that location. And usually is some unwanted material in there. So there are some stuff in there, it's going to go pick it up. So it's not going to be zero, it's not going to be cleaned up. So it's a good thing that every time we have a variable defined, we set it to 0, that way we don't have to worry about it. Yes, sir?
Do you change the order, like say 26.3 equals MPG and we'll do the same thing?
No.
It has to be left side, right?
The right side always goes to the left side. If you put 26.3 equal MPG, what's going to do is going to go try to get MPG, which in memory is going to be something, some junk, and then it's going to try to put that one in 26.3, which is not going to be possible for the compiler to do. So you're going to get a compiler error. No, you cannot do it that way. That's why they keep saying it as assignment. The right side is going to be assigned to the left side. That's the way it's going to work. Good question. When we are assigning things, we can do it three ways. One is to define or declare our variables, then we can assign it to some number anywhere in our program. Then the other one is when we are declaring it, at that time I can put the number for it. Okay, if I put a 0 without the dot, the compiler is going to give me a warning, not an error. It's going to give me a warning. It says, you know what, you're putting an integer into the double. Are you sure you want to do that? And then we're going to have this way to do it. We can put a parenthesis and put the value in it. So MPG parenthesis 26.3 is the same as MPG equal 26.3. Christina, are you okay? Okay. Now that we're taping these things, I got to be careful what I'm saying in the classroom. Volume is a variable. The question is, what is a volume? Volume is a variable that we are declaring it right now, and we're going to put something in it later on. It doesn't have no meaning. It's just a variable you created. They're all doubles. That's correct, because they are separated by comma. That's correct. So if I use volume on the right-hand side of an equation, then it's going to go pick up some junk in it, and it's going to use that one. So in this case, I am almost sure that the volume is going to be on the left side of the equation. Because if it's on the left side, I don't have to worry about initializing it. But for me not to worry about these things, every time I create a variable, I just initialize it, not to worry about it. It's your turn. Write it down. Get a piece of paper. This is for you to do. wants to go first? Declare and initialize two integers. That's going to be set to 0. Yes, sir.
Yes.
Go ahead. Didn't you raise your hand?
Yeah.
Okay, then go.
So, see, you mean you write the
Uh-huh.
int
Int,
feet,
feet,
assign,
equal,
equal,
0, comma,
comma, inches,
inches, equal, 0, semicolon. All right, that's good. Next one, declare and initialize. Yes.
In brackets too, right? So brackets.
You can put it in the parentheses, not bracket. Parentheses. Next one, declare and initialize two variables, one int and one double. Both should be initialized to appropriate form of a 5. Who's going to go next? Got so many hands. Yes, go ahead.
Int
Int,
equal 5, semicolon. Double inches equal 5.0, semicolon.
very good. So when you're doing the double, you're going to put the 5.0. So we got int. What do we have? What's the variable name?
Doesn't say slashes.
Okay, so we put the int feet equal 5 semicolon, double feet equal 5.0 semicolon. Okay, now we're looking for good variable names for identifiers to store the speed of an automobile. What would you put in there? Yes, sir. Say it again. Velocity. Okay. No, hold on. Let's talk about the first one. He's got the velocity. Who else has something? Yes. Yes. What do you mean I don't got anything? What have you been doing? The speed of automobile. Give me some variable. I'm going to give you a program. Inside your program, what are you going to put as the speed of the car? The speed. What's wrong with the speed? Yes, Christina. Miles per hour. What? MPG? MPG, miles per hour. Yes, sir. Which one? Miles per hour, okay. An hourly pay rate. Over there, sir. What's his name over there? No, him. Pay underscore rate. I like that. Yes, sir.
dollars per hour.
Dollars per hour. What is pay rate? Okay. Wage. Hourly rate. Are you getting some ideas? Are you on the Facebook or are you with us? Okay. I cannot see your computer from here. So if it's just like that, I would just put hourly underscore pay or underscore rate. That's just that. The highest score on an exam. How we put the highest score in an exam? Okay. Highest underscore score. What else? Max score. Tallest. Where do you get the tallest from? That's why I didn't want to add you to the class. Okay. We good? Questions? We can do this as a quiz, huh? So I would grade you to be sure you guys doing it. Because I asked you to do it and half of you haven't done it. Input, output. Okay, so when we have a writing program, we have some data coming into the program and there are something going out of the program. And a standard way of things coming to the program is a keyboard. So you ask a user to enter something and then you they put it and then you take that to the keyboard. That's called a standard input. Or you can read it from a file. Same thing with the output. I can write it to a file or I can write it to the monitor. When do you choose to write to the monitor versus to write to the file? What would you want to write to the file instead of the monitor?
Save space.
Well, you know, if I'm running my programs in the middle of the night, I don't want to be somebody sitting over there and looking at the monitor, right? I'm going to be writing to a file, and the next program is going to pick up from that file. That's going to be the input for another file. It's going to do its own processing. It's going to write it to another file. Another program is going to pick up that file and do whatever it needs to do. That's what's happening in it's called batch files. Those programs are running in the middle of the night because that's the slowest time on the computer system. People are not on it, so we're going to be running a lot of programs in the nighttime. And if it's running on the nighttime, I'm not going to ask, please enter your name. I'm just going to read it from a file. And then I'm going to compute, pay per hour, and then I'm going to put it in a file. The other program is going to pick it up and do salary calculation or whatever it needs to be done. But if I'm using my user and I'm interacting with my user, then I'm going to be using keyboard and monitor. So this sign is called insertion operator. That's the way we're going to define what's going to happen. So if it's going to be looking to the left, that's for the cout. Cout is our standard output that is going to go to the monitor. So here we have cout, the insertion operator, number of bars, insertion operator, double quote, and then we have candy bars, \n, and the semicolon. Number of bars is a variable, so it's going to take the value that I have in the number of bars. So if I set it to 0, it might be 0. If I change it to a number, it's going to put that number in there. And then candy of bars is going to display just like that because it's inside the double quote. \n is the carriage return. It's going to go to the next line. What is another option for carriage return? For those who wrote your own program. ANDL, thank you. So we have different way of doing the cout. We can put it all in one line, or we can put it in a different line. And the third way is if I don't put a semicolon here, I do not need the word cout over here. So I can put bunch of the couts, like the one that you did, the last assignment of a previous chapter. You don't have to put cout. You can just put one in there and put a semicolon at the end. So as far as you only have one semicolon, you need one cout. Yes, sir.
Is there a way to put a space without using print? Without using quotes?
No. So the space is one character.
So you have to use.
Yes. I mean, you can define a variable as a space and then use it in your program.
Like, so if you have cout, and then you have total cost and price tags, like how do you put a space between them?
Right here,
You have to
I just put a space right there between the $sign and the double quote. If I need a space, then I write in the, okay, right after, you talk about this one right here, right?
Or what if you just have a bunch of like
Variables.
variables?
Okay.
You should print some spaces.
All right, good. We're going to talk about that in about 5 minutes. What we're going to do, we are not going to put the spaces. What we're going to do, we're going to change the size of it. So if I have 2-digit number and I print it in 10-digit without, with the spaces in there, so it's going to have 10 of them. We're going to look at it very soon. Good question. Okay. Include directive is, as we talked earlier, and we're going to talk more and more, that we are going forward toward reusable code. So if there are some codes out there that we can use, this is not your own program copying and pasting. This is some code that is to use. We can use #include. This will go to the library of the current editor or compiler that you have, and it's going to pick up a bunch of code and actually physically put it in top of your program. So even though you write 2 lines of program, all of a sudden the size of your code, you can check the file obj, that's the object file that's been created from your file, that you can see the size is much bigger than your text file, because it's going to put these things physically in top of your program. So which pound include do I need? As you go along and you learn more, you know which ones do you need to put it up there. And the idea that they are grouping it like that is, if I don't need it in my program, I should not put it in there. I had a student last term that he was putting like 15 of these things on top of his program. It's okay, it's going to work, but it's going to have a lot of things in there that you don't use it. And the last one in there is called using namespace std. Just a brief description of that. You will learn it when you learn about the classes and object and all those things, that if I'm using something that belongs to another place, I have to identify where is it coming from. So because the cout is belong to a class called std, if I don't put this one here, every time I'm using a cout, I have to put std : cout. When I put this one here, it says, okay, I am using the std as a namespace, so every time I'm using the cout, I don't have to put that std. Automatically, the machine is going to put in there for me. I don't have to worry about it. So you're going to need these two on top of your program. Remember, in your editor, you can create your template. So you can put these things as a template for your editor, and your program is going to come up with these things already. You don't have to type it every time. So two ways of doing carriage return: \n, endl. So \/ means escape character. When I have double quote is a string, and basically it does not care what I have inside my double quote. But if I have a \, then the compiler is going to say, okay, something is happening over here. Then I'm going to go look at the next character. So \/ is going to force the compiler to look at the next character. So \n means carriage return. \t means tab. And we got a bunch of those things. We got \r, we got \0, which is the they have a special meaning for that. There's a big list of it over there. Now, what about if I want to just print a \? Remember, \/ to the compiler is what? It's looking at something after that. So we're going to put two \ to print actual \. And if I want to print double quote, then I put the \ in front of it. So \/ double quote and \/ means \/ double quote means double quote. So for some of you later on, we're going to look for a file to bring to the program. The \/ we have to put two of them in there. Now, we're going to be talking about some formatting, so I'm expecting this to be applied to all your program moving forward. And this is because, especially if you have a decimal point, your number can come with bunch of decimal points. So 78.5 can come up as 78.5 or 0.50 or 5000, and the E means what? Scientific notation. That's going to be 10 to power over 1. But most of the time we want to do it what? 2 decimal point or something like that. So we're going to do formatting. Okay? This is the way we're going to do formatting. And I'm going to call your name. You're going to come here on the board. You're going to do this. One of you, you lucky one, is going to come and do this. So we're going to have it fixed point. We're going to show the point because I want to see it even if there is nothing in there. And I'm going to set it to 2. Okay? So I'm going to say it's going to be fixed. It's going to be showing. So if I have 5 point, it's going to show 5.00. And then it's going to show only 2. So the price ENDL is going to come up as just 2 decimal point. The other insertion is for cin. So if I'm reading it from the keyboard, you can see the direction is on the other side. So you can think that it's going to take it from the keyboard and put it in this variable right here. So here I'm reading a number of bars and I'm reading one weight from the keyboard. So the user doesn't know what I'm waiting for. That's why I have to have some cout for the user I say these are the things that I need from you. C in just like C out, I can put them in all in one line, or I can separate them by different lines. So I could put C in V1 semicolon, C in V2 semicolon, C in V3 semicolon, or I can put it this way, it doesn't matter. So somehow, somewhere, we're going to be talking to the user to tell them what is it expected, so they can put it. This is the place that we're going to be careful with the spaces. When you display something, you're going to be sure that they are not crunched to each other, or you're going to have enough spaces for readability. So you can see right here, we inserted a space before W, so when the H comes, it's not going to stick to the W. So we're going to put some space here. And remember, \n, I can put it in the middle, I can put it at the beginning, I can put it at the end. Anywhere I want to go to the next line, I can put the \n. And in this case, I have ENDL. Okay, it's your turn. We ready? No. You're supposed to take notes. How are you going to do it at home? I guess you can look at these things. So, you're looking at this one? Is this the one you want? This is the one you want. How in this one? Correct. So in this case, we're going to do 4. Okay. I don't have the list of names over here. Who do we go with? Yes, sir. Right here. You calling for me? What do you got for the first one? You just don't look at me. It doesn't mean I'm not going to call you. Come here. Put it on the board, please. You guys are going to be waiting for the last one, huh? You better be ready. Scene. That one. The underscore number What's wrong with that? Here we go. Got it. Is that good? So we got seen, the number, E and the L. Yes, Roshan. Roshan. I'm going to learn your name in about 2 weeks. Yes, what? You just raise your hand for nothing?
Well, you were calling people up, so.
Okay, let me find somebody else who's not looking at me. Yes, sir, over there. Yes. Yeah. The next one, please. Don't worry, I'm going to call you next. You're so enthusiastic to come over. It's a good idea to have this as a quiz, huh? That way we can keep track of what you guys are doing. I'm still trying to find some seat for this gentleman over here. See out, write the output statement to prompt the value to store in the number. So the
You're telling the user to enter the number? Is that what that means?
no, you're going to display that to the screen.
Variable?
Yeah, just say the number is. That's okay. You can finish it up. The number. Yeah. The number is, and then the space. We are not going to put the carriage return because we want to have it right next to each other, right? So you're going to put another insertion point. No, right there at the end of it. Yes. Okay. And then you're going to put the number. Semicolon. Good. Is that okay? Okay, how do we produce a new line? Yes.
Do you want me?
Yes, go ahead. So you guys are getting ready for number 4? We're going to have the... Do we have those noises over here? Drum roll for number 4. I know Christina want to do it. Semicolon. Good.
I'll fix this.
No, that's okay. So backslash n inside the double quote or ENDL by itself is going to give me a new line. So who's a brave person for number 4? Come on down. What's your name? Jolson. Forward slash. That was actually in somebody's program. What's going to happen if I put forward slash instead of the backslash? Remember, the compiler is only looking for the backslash. So if it's not there, what's going to do? It's just going to print exactly what I have in there. So if I have forward slash n, it's going to print me forward slash n. And please look at your output before you submit it to me. So he's got cout.setf iOS fixed, cout.setf iOS double colon show point, and the last one precision 4. Is that good? Thank you, sir. Yes. Actually, there is a way to abbreviate it, but for now, yes. Okay, let me say this. Almost anything that you think of, you can do it in C++. So the question usually is not if I can do it, is how I can do it. 2.3 Data types and expressions. Okay, now we're talking about the sizes and how we're going to change this or how we're going to do this. The requirement for this class was Math 9, so I guess, I imagine that you know the difference between the whole number and the real number, that the whole number doesn't have any decimal points, and real number is the one with decimal points, or natural number, or the positive numbers with no decimal point. So we can save the numbers and show it in different format. We know about that. So if we talk about the integers, it is numbers with no decimal point. So I have 34, 45, 1, 89. Of course, we can put -1, -55, and 0 in there as well. And then when we're talking about the decimal ones, we have 34.1, 23.0034, and we can write it as a scientific notation. So we can put a E17, E1, that's 10 to the power of 1, 10 to the power of 17. So we can use that. And E to the -6, that's going to go to the left, right? You guys know these things from your math class, right? For those who took the math class or taking the math class. Yes, sir.
When I do this Cout precision, when it prints, or like when it does the Cout for number, it adds a bunch of random numbers to the front. And it's like exactly the same.
Okay, we can look at it after we finish this. No problem. Okay, now we're going to be formatting this. Okay, precision required, so we're going to use those. All right, one of the reasons that we are doing this in C++, Java, and C is we want to be efficient in the memory. If I don't need that bigger space, I'm not going to use bigger space. How do I know how much I need? Well, part of it is going to be experience, part of it is going to be catching the errors and fix it. So starting with int, when I was writing programming in the C programming, int was machine dependent. So if I would go from a 32-bit to 64-bit, my integer size would have changed from 32 to 64. So that was causing us problem, and we were asked not to use int. I don't think you have the same problem now, but we're going to leave it alone. So we have short, which is 2 byte, means how many bits? 16 bits. That means I can have numbers from -32,000 to +32,000. So that means if I go beyond the 32,000 or 32,767, something is going to happen that I'm not expecting. Then I go back to 4 byte, which is how many bits? 32. Now I can go from 2 gigabyte, -2 gigabyte, -2 billion or 2 gigab to +2. Okay, so that was when we have a 32-bit machine, we could only address 2 gigabyte. We could only address 2 gigabyte, and that's one of the reasons that we are moving from 32-bit to 64, so we can address in the memory more than 2 gigabyte. We want more gigabytes. So if I have a 32 machine that can address only 2 gigabyte and I put 4 gigabyte of RAM in my computer, what's going to happen? It's not going to even read it. It doesn't know how to read it. So that's something in that area. So float is also 4 byte, which is 10 to the power of -38. That is 10 with 38 0 in the front of it, and negative to the positive. Double is double size of that. So do we going to be having a time in our life that we're going to have a number that's going to be greater than 10 to the power of 308? I don't know. I haven't seen it. But if you have it, then you go to the next one, which is long double. That's going to have 10 to the power of 4932. So those are the sizes that we have for these, and those are going to be assigned in the memory. As soon as my program starts running, it's going to go and figure out those things. So when I was writing in the C, they were asking us to do long and short. We were not allowed to use int, but you guys are okay, you can do it. The next one is a char. Char is one character. I think we went over the ASCII table last time, and the one character is going to be 1 byte. So it's going to be smaller than the other ones. But this is only one character. The way we're going to assign one character is one single code. So it's just one character. That is different than the A with double code. Double code means it's a string. A string is going to be looking at another character, which is a null character. So the one with the double code, the size of it is 2 characters. So I need 2 bytes to store this one. With a single one is only 1 byte because it has a null character after this. So if I have defined as a char, it's going to read 1 character and it's going to stay right there. So we're going to read 1 character and then we're going to read 1 character. It doesn't matter if I have a spaces between them or not. It's just going to read 1 character. So this is a sample display 2.3, which has symbols defined here. I can define symbol 3 as a space, or I can call it the space over here, and I just print out the spaces as I go along. In C language, we did not have a string. C++ brought the string later on. We will look at this on chapter 8 at the end of the course. We're comparing the C string versus a string, and we don't have to worry about it right now. The bottom line is, if you have something that you want to keep it as a string, you can put it in there. String is not a native C++, so when you type it in your editor, the color is not going to change. It's not going to see it as a different color. And you're going to be doing a double quote around it. You do need pound include the string. Some of the newer editors would bring that automatically part of the IO stream. Even the IO stream is part of that anyway. So if it doesn't have it, then you got to put it in. So we have the program running, and then we're going to be reading some kind of string. We can add the strings together. So I can have this string plus a space plus another string. We can add the strings together. Okay, now we looked at the sizes, and we know that some of these are smaller than the other one. So we can convert them together to each other. That's nothing wrong. We can do it, but we have to be careful. So if I have an int variable and I'm going to put 2.99, what's going to happen? Because this integer is going to read the integer and it's going to stop right there. If I had a number like this and I'm going to force it or assign it to an integer, it's going to lose the decimal point. If I'm reading it from the keyboard, it's going to stay right here. If I'm forcing it, it's going to lose the decimal point. If I put an integer inside a double, it's just going to add the zeros to the end of it. So the 2, because it's going to be integer is smaller than double, it's just going to add 0.00 to it. It's going to give you a warning that yes, what you're doing, but it's going to do it. So we can force one to be the other one. The easiest way that I learned to do it is I put this inside the parentheses. So if I have an integer value, I can put double inside the parentheses in front of it, to the left of it, and that's going to force it to be double. If I want to force it to be integer, I put int inside the parentheses, and that's going to force it to be integer. Now, if I have integer, okay, character. Character, I can store the value of the character. So I'm forcing a character to be integer. In here, I'm forcing a character to be integer. So what's going to happen? It's going to go to the ASCII table and it's going to get the number. Actually, C++ is comfortable with numbers and basically save everything as a number anyway. So the value of A is going to be 65. That's going to be saved as an integer. Or if I have a char and I put 65, it's going to save A in there. So it is automatically going to transfer them or change their type. So C++ tries very hard not to crash. So it's trying to accommodate as much as possible. Next one is called Boolean. Boolean is a true or false. We can define variables as a Boolean. That's going to be defined as true or false. Or we can use integers. Integer can be 0 and 1. Technically, from the integer point of view, 0 is false. Everything else is true. So 255 is true. Negative 35 is true. 0 is false. So when you're writing program and you do return as 0, that means we don't have no errors to return back. 0 is false. So any non-zero integer is stored as true, and the 0 is stored as false. But if I declare it as Boolean, I can define it or put a value of true and false in it. T-R-U-E. You can just put that one in there. From the arithmetic point of view, we have addition, subtraction, multiplication, division, and almost any other arithmetic you have in the math. So I can use it once again. The right side is going to be calculated. It's going to be assigned to the left side. So we can mix it up. But if I have integer and integer, the result is going to come integer. If I mix it up, it's always going to promote it to the higher one. So if I mix integer with the double, it's going to change my integer to double. The result is going to come out as a double. Now, if I am dividing an integer by integer, my result is going to be integer. Dividend is what? 5 divided by 3. What do you expect to get here? 5 divided by 3 is 1. It is not 1.66, because integer divided by integer, the result is going to be integer. We have to be careful with that one. Pardon me? If I want to make this double, I'm going to put a parenthesis in front of this and write double in front of this dividend, or I'm going to put a parenthesis in here and make this double. So if one of them is double, or anything in that equation is going to be double, everything is going to be changed to double. But if they both are integer, the result is going to be integer. It doesn't matter what is this one. It doesn't matter what's the left one. The result of this is going to be integer. Yes, sir? No, if it's input as a double, it's going to calculate it as a double. If it's input as an integer, then it's going to be, so it's going to go with whatever type you define it. So here, what we have? We have double, so it's going to be using it as a double, right? So it's going to give me 1.66 as a double. So here it's going to be integer. Now we're going to have 1 instead of 1.66. Okay, another thing that we can use is a percent. And that only works for integers, because when I divide a decimal by decimal, I do not have any remainder. I'm going to get a number with a decimal. But if I divide 5 by 3, which are integers, I'm going to have a remainder, which is what? 2. So that's the way I'm going to find the remainder, which is going to be the percent. Percent is going to be showing me the remainder. Now here is talking about putting some spaces to make your code a little nicer to be able to read. So if I have x plus y times z, if I put some spaces between them, it's going to be easier to read. The rule of precedence of the operator is going to be working here. But if I don't want to think about it, or I don't want my future programmers to think about it, I just put them in the parentheses. So x plus y times z, the multiplication comes before plus, so it's going to do y times z first before it does the addition. If I don't want to think about it that way, I just put parentheses all over the place. I don't have to worry about it which one comes first. One of the things that we can use to shorthand, remember, if the right side is going to happen and then it's going to be assigned to the left side. So if I have a count, I want to add 2 to it and assign it back to it. This is the way we're going to do it. We're going to use the original one, we're going to add to it, and we're going to put it back. So if my count is 1 initialized, I'm going to add 2 to it, it's going to be 3, and put it back in the count. So now I have 3 as a count. I can go back here, and then it's going to be plus 2, that's going to be 5, put it back to the count again. Now, if I don't want to write this count again, I can put the plus equal. So plus this one and that one is exactly the same thing. So count equal count plus 2, count plus equal 2 are exactly the same thing. We can use the same thing for the star, division, and remainder. Any questions on this? Okay, last thing we're talking about the simple flow. I'm not going to do this right now. I'm going to leave it for Monday. We're going to go over this Monday. I think we covered a lot of things today. We're going to talk about the flow of control on Monday, section 2.4 and 2.5. We're going to do it Monday. I already turned on your next assignment, which is assignment 3 for this chapter, and then you can read this stuff. If you don't get to this one, we can we're going to cover it on Monday. I put your assignment due by next week. You have 1 week to work on it, actually Tuesday night. Let me know if you need more time, we can figure it out. Any questions on this stuff?